In this demo, we will create a context to interact with our database. That context represents a session with the database, and it can be used to query and save instances of your entities. To be able to do that, we first need to add the Microsoft.Entity Framework core package. We previously learned how to add packages via the NuGet dialog and via the Package Manager console. There's another way, via the CLI. We're looking at a command prompt at the level of the directory where our project lives. Here we can execute .NET add package. We pass through the package name, so Microsoft.Entity Framework core. Optionally, we can pass through --version to specify the version number. If the version number is not specified, the latest non-pre-release version will be assumed. Let's be explicit about it. So we pass through --version 6.0.0 and we press enter. And there we go, the package has been added. And with that you now know about 3 different ways to accomplish the same task. Simply use the one that you prefer. Alright, back to Visual Studio, where we want to add a new folder. Let's name it DB Contexts. And let's add a new class to it, City Info Context. So we choose to add a new class, we give it a name. That's City Info Context. And there we go. We let this class inherit DB context. That's defined in Microsoft.Entity Framework core, so we import that namespace. Bigger applications often use multiple contexts, hence the DB contexts folder. For example, were we to add some sort of reporting module to our application, that would fit in a separate context. There's no need for all the entities that map to tables in a database to be in the same context. Multiple contexts can work on the same database. In our case, we only have 2 entities, so one context is sufficient. On this context, we now want to define DB sets for our entities. We still need to import the cityinfo.api.entities namespace for that, so let's import that namespace by pressing enter. Such a DB set can be used to query and save instances of its entity type. Link queries against the DB set will be translated into queries against the database. We do see a warning here. We get a message that the non-nullable property cities must contain a non-null value when exiting the constructor. What's going on here? Well, our properties are not marked as nullable. We don't want cities or points of interest to be null. One of Visual Studio's analyzers is warning us about the fact that we haven't initialized them, which might result in null reference exceptions later on. However, sometimes these analyzers don't know everything about the codebase they need to know, and this is one of those cases. Behind the scenes, deriving from DB context ensures that these properties are initialized as non-null after leaving the base constructor, so this warning can be ignored. For that, we can use the null forgiving operator, which was created with this scenario in mind. The null forgiving operator looks like this: NULL! Our application will use this context, so we need to register it so it's available for dependency injection. We already know how to do that, as we've encountered dependency injection before. Let's open the program class. Here we can register this DB context by calling into addDBContext. This will register it with a scoped lifetime. We do need to import the cityinfo.api.dbcontext namespace. And now we need to connect to a database. The first thing we need to do is choose a database. Let's open the NuGet dialog. And let's search for Microsoft.Entity Framework core. You see there's quite a few packages listed here, including packages with providers for each database you may want to integrate with. There's packages for SQL Server, there's an in-memory provider, a SQLite provider, Cosmos, and so on. We're going to use SQLite, as that is supported on all platforms and in all IDEs. Let's add it. As we've installed Microsoft Identity Framework Core version 6.0.0, prefer to keep the related packages on the same version number. So let's add version 6.0.0. And there we go. Entity Framework Core supports lots of other providers. You can find an overview of them on the link on screen, including how to set them up and use them. So if you need to integrate with any other type of database, here's how to set up the connection. Back to our code. With that, we can now connect to a SQLite database, but we still need to let our DB context know where it can find that database. We do that through a connection string, and that needs to be provided to our DB context. In other words, we need to configure our DB context. There's essentially two ways of doing this. The first way is through overriding the onConfiguring method on the DB context. So we've got onConfiguring here, we override it, and on the options builder, we can call into a method, useSQLite. That method is available thanks to the SQLite provider package we just added. The parameter we need to pass through is the connection string. This tells the DB context it's being used to connect to a SQLite database. So that's one way. But let's look at the other way, which is via the constructor. So let me comment this out and let's have a look at the DB context's definition. It exposes a constructor that accepts DB context options. So maybe we can use that one to configure our context. Let's add a constructor that calls this constructor overload. So we add a new constructor for our CityDB context. We pass through DB context options on CityInfo context. And we name that options. And that's what we pass through to the base constructor. And there we go, that takes care of that. By exposing this constructor, we can now provide these options at the moment we register our DB context. That's what we did in the program class. There's a method overload we can use here. So we configured it by passing through an action. On DB context options, we call into useSQLite. For that, we need to import the Microsoft Identity Framework Core namespace. And we also pass through a connection string. For SQLite, the connection string can be pretty simple. We state that the data source will be a file named cityinfo.db. It will live in our application root. Other database providers might have more complicated connection strings. If you need one of those, have a look at the documentation that comes with the provider. We still haven't got a database though. This is a code-first approach for the new database, and we have now defined all that is needed to generate it. Let's learn how to do that in the next demo.